We're going to look now at an angle of depression question. So in this particular example, it tells us the highest point along the cliff of the Scarborough Bluffs in Toronto is 90 meters above the shore. From the top of the cliff, a surveyor spots a boat in the lake at an angle of depression of 43 degrees. So how far is the boat from the shore to 1 decimal place? So first thing that we need to do is we have to draw the diagram. Okay, so it says that it's the top of the bluffs. Bluffs is a cliff. Okay, so in Toronto it says that it's 90 meters up. Okay, so this particular height is 90 meters. Then we've got the lake. Okay, it's my lovely rolling lake. And we're going to draw in the boat. My lovely little boat. Okay, so there's someone standing at the top. So it says, from the top of the cliff, a surveyor spots a boat. Okay, so here's our surveyor. He or she is up there looking down at the boat, and so they can see the boat from the top. So we can say from the top of the cliff to the boat makes part of a triangle. Okay, now, and we could probably just erase bits and pieces of that. Okay, so they're able to see the boat from the top of the cliffs. And it says that they're looking at an angle of depression of 43 degrees. Okay, now remember, angle of depression and angle of elevation are always taken from the horizontal. So from the horizontal, that would be this height. Okay, so the angle of depression is actually right here. Okay, so that's our angle of depression. That's 43 degrees. Okay, now, if that's our angle of depression, we got to figure out, well, how far is the boat from the shore? Well, in this instance, we can determine that the height, the other part of this particular triangle is actually here. Okay, so from the boat up to the top, that makes the other part of the triangle. Okay, and so the height of that particular piece of the triangle is also 90 degrees, or sorry, 90 meters. Okay, and the reason it's 90 meters, and this is a 90-degree angle, and this is also a 90-degree angle. Okay, so we can figure out how far away this boat is. And the reason we can do that is that this is actually just, it's a triangle, or, sorry, it's a rectangle rather. Okay, and so as a rectangle, okay, you've been given this angle right here, and that we know that that angle is 43 degrees. Okay, so this is a right angle, this is a right angle, same deal. The boat's down here. Okay, and because these sides, it's a rectangle, these are all parallel. Okay, so if you remember back to grade 9, some of the conditions around parallel lines, you have the length of one side length of a rectangle is the same as its opposite side length. So the cliffs are 90 meters tall. From the water to the top of the cliffs, if you were to draw a line straight up, as this red line is, that's also 90 meters. Okay, so now we've actually drawn this out. So we can now go through and we can figure out just how far away this is. So we want to figure out the value of the boat from the shore. So if this is the shore here by right in that section, if that's the shore, then we know that the distance, that is from here to here, is the same as the distance from here to here. Okay, so both of these are equal to x. They're the same thing. We're trying to figure out now what that length is. Okay, so we can then go through and we can label this triangle and we can solve this particular problem. Now, really, there's two ways to do that, but the way I'm going to show you is using the angle of elevation. So our angle of elevation, we've got, first off, label this triangle. So we know that the hypotenuse is right there. Okay, the side that is opposite of the angle in question is right there, and therefore the x has to be our adjacent side. So if we want to figure out which trig ratio to use, again, we go through, we do so, ka, toa. Okay? So what are we trying to solve for? Well, we need to figure out the value of x. That's the adjacent side length. Okay, so the adjacent side length is what we're looking for. And the information that we have, we know what the angle is. Okay, and we also know the value of the opposite side length. Okay, um, and so based on this information, the ratio that we need to use is actually our tangent ratio. Okay, we don't have enough information to use the the sine ratio, because it doesn't give us the value of the adjacent, and there's not enough information to use the cosine ratio. So we're going to use the tangent ratio. So in this case, we've got tan of x is equal to the opposite divided by the adjacent. So tan of 43 degrees, because 43 degrees is our angle of depression. Always looking down, that's why it's depression. Okay. So tan of 43 degrees is equal to, in this case, 90 over x. Okay, so our opposite divided by our adjacent. Now, we've already talked about how any number can be written as a fraction, so tan of 43 degrees can also be written as a fraction, so we're going to do that. And then what we're going to do is cross multiply. So we're going to take tan 43 degrees times x is equal to 90 times 1. Okay, well that's going to give us x times tan of 43 degrees is going to be equal to 1 times 90, and 1 times 90 is just 90. Okay, so now we've got to get x all by itself. Well, in order to get the x term all by itself, right now it's being multiplied by tan 43 degrees. So we actually have to divide both sides by tan 43 degrees. Okay, remember, tan 43 degrees just represents a decimal number. So we can divide any number by any other number. Okay, so tan 43 is what both sides are going to be divided by. So if we go through our process of elimination, tan 43 degrees divided by tan 43 degrees, those actually cross out. They cancel each other out. So you're just left with x is equal to 90 divided by tan 43. And 90 divided by tan 43 is going to be equal to 96.5 approximately. So 96.5. Okay, so in this instance, the boat is 96.5 meters away from the base of the cliff. There is another way that you could take a look at this. Again, we can use the same basic formula, and I'm going to just quickly add another page. And I'm going to redraw this. Okay, so here again, we've got the surveyor at the top. Give him or her some legs and arms. Okay, we know that the boat is in the water. It's my lovely boat. We know that he's looking at an angle of angle of depression rather of 43 degrees. Okay, so this angle in here is 43 degrees. Okay, and this is going to be a 90-degree angle. Okay. Now, one other thing that you could be aware of is that you may recall back in grade 9, you looked at different patterns dealing with parallel lines. You looked at the F pattern, the C pattern, and the Z pattern. And one thing to be aware of with the Z pattern, because you actually have a Z pattern right here. Okay, that's a Z pattern. The inside patterns actually mean that the angles are the same. So 43 degrees up at the top is the same as 43 degrees down here. Okay, so this is just another way to look at this particular problem. In this case, we know that the height of the cliff is 90 meters. So if we take this particular triangle and we're trying to solve for this value because we want to know how far the boat is from the cliff, we can do that uh, again using our SOHCAHTOA. So we know that what the angle of we know that the angle of depression is 43 degrees. That means that the angle of elevation from the boat to the surveyor is also 43 degrees. So let's try and solve using this piece of information. Okay, so let's put in our SOHCAHTOA. So again, this is just a different way to approach the same question. So we are going to label our triangle. Here we've got our hypotenuse. Now we've got our opposite, and x is going to still equal our adjacent. Okay, just like it did in the previous example up at the top. So now we got to determine, well, what are we looking for? We're looking for the a value, so we can underline the a value, so we can't use the sine ratio. That's not going to help us. Other piece of information that we know the value of the opposite, and we have the angle. Okay, so based on that, we must therefore, again, still use the tan ratio. So if we go through and we solve, we're going to go tan of x is equal to the opposite divided by the adjacent. We're going to substitute in our values. So tan of 43, because we got an angle of 43 degrees. Our opposite is 90. Our adjacent is x. Okay, we've seen this. We saw it above. Okay, we know that we can turn that tan 43 into a fraction, so we've got a complete fraction, and now we're going to cross multiply. So we end up with 90 is equal to x times tan 43 degrees. We know that we've got to get that x term all by itself, so that means we have to do the opposite operation of multiplying by tan 43, which is dividing both sides by tan 43. Okay, and so we're going to end up, again, with 96.5 meters. Okay, so either way that you approach this question, you will still get the same answer. And it doesn't particularly matter to me which way you approach, but you need to recognize and draw in your diagram that you know where the angle of depression is. And it's important to note that the angle of depression is also equal to the angle of elevation. Okay, so just be aware of that.